Hi, my name is Greg, and I wanted to show you a sample PV equals nRT problem. So we're told to calculate the mass of 40 decimeters cubed of sulfur dioxide gas at 100 degrees Celsius and atmospheric pressure of 1013.25 hectopascals. We know that the AR of sulfur is 32.06 and we know the AR of oxygen is 15.999. Let's see what we can do. We know that, if I don't scroll up accidentally, maybe I'll change color for this actually, we know that the pressure is equal to 1013.25 hectopascals. But we don't want the pressure in terms of hectopascals, we want it in terms of just pascals. So to get from hectopascals to pascals, you'll multiply by 100 because 1 hectopascal is 100 pascals. So you'll multiply by 100 to get 101,325 pascals. And that's our pressure. We know the temperature is 100 degrees Celsius, but if you remember from the last video, we don't need the pressure in terms of Celsius, we need it in terms of Kelvin. So to go to Kelvin, we need to add 273 to our 100 to get 373 Kelvin. Okay, now that we've done that, we also know that we've got a volume of 40 decimeters cubed. Oops, 40 decimeters cubed. But that's not really what we want. We want the volume in terms of meters cubed. Now, 1 meter cubed is 1,000 decimeters cubed. So I'll divide by 1,000 to get 0.04 meters cubed, and we're almost there. Now remember, the gas constant is always 8.31 joules per mole per Kelvin. Okay, and we know our equation, I'll put it next on the side kind of, PV equals nRT. What I'm going to be looking for is really the number of moles, right? So PV over RT will get me a number of moles equals N. And now we can actually get the equation, so we can say that N, the number of moles, is equal to PV, so our pressure, 101,325 pascals, times by the volume, which we know is 0.04 meters cubed, divided all of that by RT, which we know is R, 8.31 joules per mole per Kelvin. And we need to multiply this by the T, the temperature of 373 Kelvin. So let's just consider maybe how our units will... Actually, I'm not going to consider the units, I think I've done that in the last video. So if you want to check up on your units, you can do that in the previous one. All I'm going to tell you now is that the answer, once you put this through a calculator, gives you about 1.308 moles. I've done this to 4 significant figures. But here's the question. The question says, calculate the mass of sulfur dioxide, right? Not the moles. So we've got to get a mass. And the question specifically tells us the AR of sulfur and of oxygen. So we know the AR of sulfur is 32.06. Forgot the 0.06. And we know the AR of oxygen is 15.999. And we know we've got 2 oxygens, so I'll multiply that by 2. And now we know the MR of sulfur dioxide is equal to 64.058 grams per mole. Now we know N, the number of moles, times the MR gets me a mass. So if I take my moles here, which is 1.308, so 1.308 moles, and multiplied by my MR, if I could do it without scrolling accidentally, 64.058 grams per mole, I'll get my final answer in terms of grams, which is equal to 83.8 grams. And we're done.